All right, so we're going to be looking at similar triangles and an example of them. So in this example, we have a triangle that was drawn, and then we drew a line inside the triangle that will be parallel to one of the sides. A common example of where this may occur in real life would be if you had to change the roof span of a house. And so here would be your rafter in the beginning, and then you change it by coming in some. So you change it from its original roof span, and then now you need to find out, well, what's that new length? So that would be an example of where you might see this in the real world. Um, Something else would be if maybe you have your surveyor from here, and you need to move something up. So maybe it's 18 feet apart, and you know, like maybe it's a hedge, and you're doing landscaping, and you need to move it up. Well, you need to know how much you need to cut off each side so that it'll fit in the new spot that it needs to. Okay. So in this example, we want to find out what is this new length here. What is this new length here, x? All right. So how do we do that? Well, because these share an angle, that angle has to be the same as itself, right? Okay. And because we had that parallel line and all we did was move up, we drew a parallel line inside the triangle. That means then that these angles have to stay the same as well. So this is automatically similar. So if you ever have a triangle and you draw a parallel line inside of it to one of the sides, you automatically have two similar triangles. Okay? Well, if these are similar, then that means there has to be a relationship between the corresponding sides. Well, that means then that if we want to, we could say, hey, 18 over x has to equal the same as 36 over 30. Okay? Yeah, that's true. Because these have to be in proportion to one another. So if this one got smaller, this has to get smaller by the same factor. So of course, sometimes people say, hey, I don't like to have x in the denominator. That's fine. You've seen how to solve equations like this before. But if you want to change it, you can. We can make this be x over 18 equals 30 over 36 instead. Now, many viewers probably looking at this and saying, hey, I know if I take 18 times 2, I get 36. So this must be whatever I get when I multiply that by 2. That is correct, actually. But before we jump there, let's talk about how you would solve this. So a lot of times people say stuff about like using cross multiplication, or sometimes people say simplify first and multiply. Whichever method you want to use to solve it, you solve it, as long as it's mathematically correct. Now, in this case, what I would do personally is I would see that relationship, that I would multiply this by 2 and get 36. So this must be the same. So that means that x would have to be 15. Now, this video was about similar triangles, not about solving equations. Now, there are other videos that you can look at to look at how to solve an equation, or if you need refresher on this. Now, I will show you how to solve it algebraically, but that is a skill that you have learned from previous usage or from other videos. In this case, I will show it, but do not expect that every time, because this is the concept here that's being taught is similar triangles. It's not solving algebra equations. And a lot of times people think that they can't do similar triangle problems because they don't know how to solve this. Well, that's a solving equations problem. Don't keep them separate. Keep them the same. This is still solving an equation. So anyway, to solve this equation, we can multiply both sides by, we could do cross multiplication, some people call it. So we get 36x equals 540. And then we could divide both sides by 36. And in the end, you see that x does equal, in fact, 15. Okay? So that means that our roof span, or whatever you want to call it in this case, whatever kind of problem this is, would have to be 15. Okay? And so that is another similar triangle example. In this case, in which you draw a line parallel to one of the sides within the triangle. Oh, that's kind of interesting. All right, so another example coming up, and I will see you soon.